Alrighty, guys, Mrs. Cameron here on CLT Math Practice number 3. We left off at question number 113, which says, if b equals a squared minus 4 and 3b equals c to the power of 4 over 12, what is a in terms of c? So I'm going to start here with that b equals a squared minus 4. And then on my second equation here, I want to get my b only by itself. So 3b equals c to the power of 4 over 12. And I want to get rid of this 3. I could divide both sides by 3, or dividing by 3 is the same thing as multiplying both sides by 1/3. That'll make those 3's cancel out like I want. So b equals c to the power of 4 over 12 times 3 is 36, right? Now I can substitute for the b's and put this equal to this for my next step. So a squared minus 4 equals c to the power of 4 over 36. Then I want to solve for a. First step to do that, get rid of my minus 4 by adding 4 to both sides. A squared equals c to the power of 4 over 36 plus 4. What's the opposite of something squared? Take the square root of both sides, and that could be positive or negative. So a equals plus or minus the square root of c to the power of 4 over 36 plus, and if I want to take this 4, I'm going to bring it over to the side here and say 4, make it a fraction, put it over 1, and I want it to be over 36. I have to multiply 36 times 4 to find my other little piece of the numerator here. 4 times 6, 20. 4 times 3 is 12 plus 2, 14, 144. 144, which this over here is a match to nothing yet. But if we take the square root of the denominator of 36, that would be 6, and then that would be a match to A. Oof. Okay, and next we have question number 114 says, integer p is the y-intercept of the line that is tangent to the graph of x squared plus 4x plus y squared equals 45 at -2, 7 in the xy coordinate plane. What is the value of 2p squared? So right here, p is the y-intercept of our tangent line. Okay, so our y-intercept. So when x is 0, what is y? And then we got to say 2p squared. and then find our answer here. Okay. So our graph of this, I want to say, okay, x squared plus 4x plus y squared equals 45. I want to factor this side over here is to put it in my circle equation. They can find the coordinates for my center of my circle. So this would be x plus 2 squared, which would give me x squared plus 4x plus 4. So I actually, I got an extra 4 here, so I got to add 4 to both sides. Plus 4 like this. And then my y, really that's just y plus 0 or y minus 0 equals 49. So that tells me that the center of my circle is at -2 for my x value and 0 for my y value. So I've got a graph like this. Ooh. Where the center of my circle is at -2. My radius of my circle is a square root of 49, which is 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So my circle is like something like this. Okay, that's not a very good circle at all. But anyway, okay, there's my circle, and let me try one more time. The top of it will be here, above the center, right? Not over to the side there. And my bottom will be here, not on the y coordinate. Okay. Okay, that's slightly better. Okay. And then it says that the line tangent to the graph here at -2, 7, so that's at the very top of my circle. So tangent means a line that touches but doesn't go through. They only touch at one point. And we want to know, what is the y-intercept? Okay, that would be here at the 7. So 2 times 7 squared. 7 squared is 49 times 2, 98. Because my y-intercept p equals 7. Okay, and then question number 115 says, an archaeologist has discovered a collection of prehistoric spears. She is shipping them to a museum using a rectangular packaging crate with side lengths of 4 by 4 by 6 feet. Assuming the spheres only come in whole number lengths measured in feet, what is the length of the largest spear that can fit entirely inside the packing crate? So we have a rectangular prism, right? A rectangular box. So I'm going to draw my 2 rectangles. and connect the corners. Okay, so the dimensions are 4 by 4 by 6. And we want to find out what is the largest sphere that we could fit across the box from corner at the back to corner at the front. So like we've just kind of made a little, call this X. And I want this to go from the corner of the bottom to that corner over there at the back. So we've got a triangle inside of a rectangular prism, and we need to find the diagonal, or that's kind of like the hypotenuse there, right? I know the height back here is 4. So we need the diagonal here across the rectangle at the bottom, our 6 by 4 rectangle. So to find my rectangle base, right? I mean, my diagonal at my rectangle base, I see a right triangle down the bottom. So I took this out and moved it over here. My width is 4. My length is 6. The hypotenuse will give me that diagonal at the bottom. So 6 squared plus 4 squared equals c squared. 36 plus 16 equals c squared. 36 plus 16. 52 equals c squared. So c equals square root of 52. And I can just leave that like that for right now. So right here, this triangle, that's square root of 52. And I'm going to erase this Pythagorean theorem over here. Remember that formula is given to you on your reference sheet. And now I'm going to do the Pythagorean theorem a second time to find out the length of this hypotenuse on this other triangle. We had a triangle at the base, and now we got our triangle at the diagonal inside. So we got 4 squared plus square root of 52 squared equals x squared. And 4 squared is 16. Square root of 52 squared is 52 equals x squared. 52 plus 16 is 68. So square root of both sides. So this diagonal is a square root of 68. I know that 8 squared is 64, so that would fit. And 9 squared is 81, so that would not fit. But C, that would fit because the square root of 68 is going to be less than 8. So that is the length of the largest sphere that can fit inside the packing crate.